Hello, everyone, and welcome to the Department of Energy SBIR STTR FY24 Phase 1 Release 2 Topics webinar. My name is Zina Al-Yusuf. I am with the DOE SBIR Programs Office, and I will moderate today's webinar and provide you with some basic topic information as it relates to Release 2. For all the panelists, if you'd be so kind to mute yourself to prevent background echo, that will be great. Thank you. Following this introduction, you will hear from the topic managers that oversee topics 11 through 22 as they clarify their expectations and answer some questions that you may have regarding their respective subtopics. During this webinar, you may submit topics-related questions via the Q&A box located at the bottom of your screen. Please include the topic number and the topic and subtopic number with your question. This is very important to help us keep track of questions during the webinar. So please include the topic and subtopic number. We will group and present the questions to the topic managers following each topic presentation. If you have a funding opportunity announcement and or other non-topic related questions, please save these questions for the Release 2 Funding Opportunity Announcement webinar scheduled for December 15. We will post the recording of this webinar along with a copy of the presentation on SBIR website under the Funding Opportunities webpage. The programs presented today Office of Energy Efficiency and Renewable Energy. This is the second of 3 webinars that will cover the Phase 1 Release 2 topics. There are 6 programs participating in this release, and we have about 117 subtopics. Today, we will
graciously agreed to the summit.
Could you please mute yourself to all the panelists? Please mute yourself to prevent background echo. Thank you. Thank you so much. Thank you. This is the second of 3 webinars that will cover the Phase 1 Release 2 topics. There are 6 programs participating in this release, and we have about 117 subtopics. Today, we will cover topics from the program mentioned. As you can see, the topics document was issued on November 6th. And this week we are hosting the webinars. The funding opportunity is usually released about 3 to 4 weeks after our topics are issued. We do this to give you the opportunity to read through the topics document and ask questions so you can make up a more informed decision as to whether or not you might have something that is responsive to what we are looking for in this release. The most important date following the opening of the funding opportunity is the letter of intent due date, which is the first step you need to make in order to submit a full application. DOE is the only federal agency that requires a letter of intent. It tells us who you are, what topic, subtopic you are interested in applying for, and a little bit about why you think you are responsive for that subtopic. So basically, if you do not submit that letter of intent, then you cannot submit a full application to the funding opportunity. As I mentioned, we have 6 programs participating in this release. We covered the topics 1, 9 through 10, and 23 through 28 on November 15, and I'm sorry, on November 14. And today we are covering topics 11 through 22. We have one more webinar left on November 16. Please visit our funding opportunity announcement page and register for that webinar. As indicated, all 3 webinars, the recordings and presentation will be posted on our website under funding opportunities page for you to access anytime you need to. The funding opportunity is scheduled to be issued on December 11. After that, we will have the funding opportunity webinar on December 15. In this webinar, you will hear from SBIR STTR Outreach Manager, Eileen Chant. She will provide an overview of the application process and go over a few changes to the program. So you will want to register for that free webinar. It is also an opportunity for you to ask questions related to the actual application process. However, today we are going to discuss the topics in just a little more insight than what is provided in the topic document. Please remember to join our mailing list if you haven't done so already, so you can receive notifications from us when topics are released, webinars scheduled, and some good information applicable to each cycle as we move through the phase 1 process. Would like to mention that we use GovDelivery as a news application platform. Please contact your IT department or IT group to allow you to receive these emails so that you get them in your inbox. I also would like to remind everyone that Phase 0 Application Assistant Program, which is free to you, is now open. The Phase 0 Application Assistant Program is available for first-time DOE, SBIR, STTR applicants. Participants receive an individual coach who is an expert in our application process, and program is open when the topics are released. And here's the link to the page and the program to determine your eligibility and apply to Phase 0. Just to give you a clear picture about our topics here, they are created by DOE program managers and define important technology breakthrough needed in the R&D areas that they support, the DOE mission. The topics are written in a way that support the topic managers in their roles in their offices. Many of these topics are related to the topics they are sponsoring in one of their universities or national labs. When you go through the topics document, you will see the topics are arranged by program offices and organized alphabetically and numerically, and that is the way we are going to refer to them. What we ask you to do first is to read the topics and subtopics and the reference information that is provided to get a little more context as to what the topic managers are looking for. When you do get in touch with the topic managers, it is for clarification purposes. We are not asking them to tell you whether or not it is a fit for what they're looking for. In other words, the feedback they give you is to help you determine whether or not your innovation would fit what they are looking for. At the end, the decision to apply is yours, regardless of what you might hear from the topic managers. The decision to apply is yours. So what's a topic look like? Here's an example for you. We always have a topic header, that is the blue bar you see below the topic title and above the description. And it gives you important information like if the topic accepts STTR, a yes or no, and the maximum award amount for that topic. Not all topics have the same information. They vary by program and by topics as well. So please pay attention to such information. The general topic description explain what the topic is about and maybe some context on where it falls within the mission of the program. Below that, you see the subtopics that are described specific opportunities in which proposals are requested. You will notice that a good number of the topics have other subtopic. Under this subtopic, you can submit proposals that fall within the general topic description, but do not fit with any of the other subtopics. After each subtopic, there is question-contact, then the name and email address of the point of contact that you can reach out to with your questions. Please note that every SBIR or STTR application must include the topic and subtopic to which you are applying for. That's just a brief overview, and now we will start with the first topic in today's webinar. Topic 11. Jeremy or Paul, are you online?
Hello, can you hear me?
Yes.
Yes, I can hear you.
Wonderful.
Yeah, excellent.
Go ahead, please.
Okay. Is there a slide for this specifically for subtopic A?
Yes. Can you see the slides? I have them.
Okay, it's just the overview that includes the summary information, the mention of subtopics A, B, C, and D.
Yes.
Okay. Yeah, I will be speaking on subtopic A. My colleague, I believe if he's on, Changwon Su will be, Changwon or Jeremy, other colleagues will be speaking on the other topics.
Okay.
So just to kick off for subtopic A, this is innovations in micro battery manufacturing. Understanding that battery and energy storage manufacturing supply chains vary in their levels of maturity and levels of robustness. Batteries that serve specifically microelectronics sensor systems and small compact microelectronic systems, due to the very, very small capacity and physical volume size, processes and supply chains often are under supported and have separate challenges. So earlier this year, we released a prize for microbattery designs, and sort of this is related to that, to the focus of that prize. The prize was focused on microbattery designs, and this SBIR is focused on innovations in microbattery manufacturing. So innovations in manufacturing methods, processes, technologies, and things specifically aimed at manufacturing batteries of 0.1 cubic centimeter or smaller. Key innovations that we are looking for include increasing the yield and reliability of micro batteries designed that are within that volume size, incorporating new or improved materials into manufacturing, seeing micro battery manufacturing as sort of a step for further development and adoption of innovative materials into into battery supply chains. And then finally, given the unique set of challenges and sort of challenges for batteries of such small capacity sizes, ways to reduce the cost for the production of micro batteries specifically is a key metric in this area of interest. That concludes my description of subtopic A, and so I will pass it over to my colleagues.
Thank you so much. Chang-won, are you online?
Yes, can you hear me?
Yes, go ahead.
Oh, okay, great. Let me talk about the topic 11B, which is about manufacturing innovation of lithium metals for batteries. Right, so lithium metal is very important materials for lithium-ion batteries, right? So it was used primarily in lithium metal batteries or pre-lithiation in advanced lithium-ion batteries. But lithium metal is obtained by extracting lithium from lithium-containing brines or minerals, right? But it's not easy to process this lithium metal because lots of the toxic gas and the manufacturing cost. What about the energy efficiency processing during the electrolysis process? So we would like to seek projects that is focused on novel, sustainable, and scalable manufacturing to accelerate this lithium metal production. So that's why we put several key target metrics, such as the reduction in manufacturing cost, reduction or elimination of toxic gas during the process, increase in energy efficiency of lithium metal producing electrolysis. What about the increase in sustainability or circularity? Right. So technical challenges include various things related to mining operations, such as cost, as well as related to energy equipment, carbon emission, something like that. So these should be addressed, from the proposal. So again, I would like to say, we are looking for proposals for developing and scaling up of innovation that improves environmental impact of lithium metal production for lithium-ion batteries. I think that's it.
Thank you. Let me see.
Nick?
Yes, there is a question. Is recycling considered a valid eco-friendly innovation topic?
Yes, it is.
Okay.
Oh, I'm sorry. This is for 11.
11B.
This is for my topic B,
Yes.
right? Yes.
Yeah.
It is.
Thank you. There's a question for 11A. Will the technology development for micro supercapacitor manufacturing fit this subtopic?
At this point in time, I would say we would need more details, more of an understanding of the function and the intended use case to be able to determine. So at this point, it's not enough information to make a determination.
Okay. There's a question. Okay, 11. No, this is 11C. Is the technology?
Yeah, I believe we have not yet given Jeremy a chance to sort of give a description on C.
I'm just
or,
looking for
or D for that matter.
Yeah, I don't see any questions for 11A or B, so we're gonna go to subtopic C.
Okay, this is Jeremy, and I just wanted to note that I think that some of the questions for topic 11C around lithium were probably targeted for B, maybe just mislabeled.
Oh, okay.
But with respect to C, topic C is sort of interested in cost-effective, scalable powder synthetic routes or powder fabrication methods for high purity max phases with harsh environment stabilities, which should be demonstrated through appropriate material characterization techniques, material property measurements. So these should be sort of embedded in the project and proposal. You know, if there is, you know, an affordable and scalable synthetic route with a high yield that can be developed with a high purity, the max powders or fabrication of max phases should have an ability to be produced both for the market based on their unique properties, particularly the operation in high temperature, neutron radiation, oxidizing, corrosive environments, and harsh industrial applications. So those are sort of the areas that we're seeking these max powders to be, and max phases to be used in.
Thank you. Let's see if there are any questions for. Let's see, 11D. What about manufacturing process for the cathode? That's 11B, I think. Yeah. Let me see. I don't. It's 11C max phase. Is there a focus on producing max phases that are precursor's to Maxon used as electrodes in battery?
Yeah, I don't think that's something we necessarily called out, so I wouldn't call it a focus, but I think if you can, you know, if it fits within that description of harsh environments or you know, high temperature, any of those sort of environmental variables that we're trying to exploit the unique properties of the max phases for, then I'd say yes, but as a focus, I wouldn't say so, no.
Do you have a specific application areas?
The application areas, I think, are more defined by the environmental conditions.
Okay. I don't see any more questions, so we can go to the other subtopic. D, Brian, are you online?
Yes, I'm here. Thank you.
Go
This
ahead.
is Brian. Thank you. This is Brian Valentine. I'm an engineer in the Advanced Materials and Manufacturing Technology Office. I'm speaking on behalf of myself and Nina Karsberg, who are the topic managers for this particular subtopic, D. This subtopic is limited to solid state quantum computing technology only. Anything other than solid state quantum computing is not responsive to this particular subtopic. Our office has had some success in what we have called atomically precise manufacturing. That is, manufacturing with precision down at the atomic scale. And some of this technology, some of this development, some of this advancement, we feel is applicable to quantum computing. And in particular, the manipulation of atoms that, or quantum dots that would serve as qubits within a solid state environment. And the requirements are the responsiveness of the qubit and the ability to manipulate the qubits in various electronic states, and the ability, of course, to interface with the externalities that are needed to interpret the superposition measurements of the quantum states that are manipulated with it at the quantum level. So the device and the device would start at the configuration of the qubit and whatever else is needed to make the interface possible with the externalities that are needed to understand what is happening there. Energy efficiency of these devices, these solid state quantum computing devices, is emphasized simply because we have emphasized energy efficiency in computing in general through all of our work with in computing and hardware, associated hardware needed for it. So I'll take any questions on anything, on any questions that people may have about what may or may not be responsive to this subtopic. And I'll finish it up here.
Okay, let me see if there are any questions. Again, for all the attendees, if you be so kind to include the topic and subtopic number, that would be great, because some of the questions are without the topic and subtopic numbers. There is a question, will devices for energy efficient traditional, also known as CMOS computing, be considered, though not specifically quantum computing?
No, this subtopic is limited to quantum computing only. And only, as I mentioned, only solid state quantum computing. No other configurations are considered responsive to this subtopic. Okay.
There is a question for topic 11, but did not specify the subtopic. Is a technology for in situ testing and micro scale material characterization of additive manufacturing materials fit into topic, into this topic 11? I guess the person is inquiring if such, what he's asking for, fit for that topic or under any of the subtopics.
I'm not sure how to answer unless it gives more information.
Okay. For the person who asked this question, please contact the topic managers listed in the on the screen, the email addresses, and also included in the topic document to get a better answer. I don't see other questions for topic 11, so we can move to the next topic. Thank you so much. We'll go to topic 12.
Do you
Yeah.
hear me?
Yeah, go ahead.
Okay, so I'm Yaroslav Chudnovsky, and I'm just managing the entire topic of C58-12 for Industrial Efficiency and Decarbonization Office. As many of you know, that Industrial Efficiency and Decarbonization Office is relatively new. It was established last year and leads the development and accelerate the adoption of sustainable technologies that increase efficiency and eliminate industrial greenhouse gas emissions. The topic number 58-12 is looking for disruptive industrial innovations, including R&D, small-scale demonstrations, and technology partnerships to drive U.S. industrial decarbonization, productivity, and economic competitiveness. We have 4 subtopics under total AIDA topic this year: enabling industrial grid interactivity, energy efficient gas separations, innovations in heat exchange processes, equipment, and integration approaches for deep waste heat recovery, renewable hybridization of the industrial processes. The specific, I just put my name as a point of contact at this point, but each subtopic has their own technology manager, and specific focus of each subtopic will be briefly discussed by corresponding topic lead. The enabling industrial grid interactivity as a topic manager, Zachary Pritchard, who is going to discuss the focus of this subtopic. Zach, it's yours.
Yep. Thank you, Yaroslav. So yes, I'm Zach Pritchard. I'm a technology manager in IEDO and our cross-sector technologies subprogram. In this subtopic, the reason why IEDO is interested in this area is that electrification is one of the 4 pillars of decarbonization that we identified in our industrial decarbonization roadmap, and it's a major focus area for our R&D and D programs. By electrifying industrial equipment and processes and using electricity from clean sources, that's a major strategy for reducing greenhouse gas emissions from industry. And so that could include generating clean electricity on site. It could also mean getting clean electricity from the grid as the grid's emission factor continues to decrease. In industry, there is certainly equipment like pumps that are already heavily electrified, but the biggest uses of energy, things like process heating and steam generation, are primarily driven by combustion and are less than 5% of energy use there is sourced from electricity. So as we think about what significant industrial electrification looks like, combined with adoption of intermittent sources of clean electricity, it's going to be both a challenge and an opportunity for industrial facilities as well as for the broader electricity system. Current discussions of kind of what the grid edge and distributed energy resources, the role that those can play, the industrial sector is often overlooked. And this is perhaps because industrial operations are usually continuous, because they're complicated, because there's not much incentive for manufacturers to participate in existing utility programs to provide ancillary services. But really enabling industry to have more flexible electric load by modulating their electricity consumption can provide benefits both to industry and to the grid. For industry, facilities would be able to optimize the use of on-site and off-site resources to reduce their emissions and to realize economic benefits, whether it's by responding to price volatility, the generation mix, or other parameters from the grid. They're also able to minimize the impact of outages, unplanned downtime, and generally improve their resilience. From the perspective of utility, industrial facilities are major energy consumers, and they can act as virtual batteries that provide ancillary services and increase resilience of the grid. This subtopic in particular is interested in innovations on the software and control side of industrial flexibility. So the focus is not, for example, on developing equipment for power generation or equipment for energy storage. That said, the most competitive proposals here are likely going to take a full energy system point of view. So we're talking about sending and receiving information from the grid, from on-site generation, storage, and other distributed energy sources, and from the facility's processes and production systems. This means that the most competitive project teams are also likely to include a manufacturer who is advising the technology development and also hopefully demonstrating the technology in their facility. Applicants need to propose metrics and topics, including increased load flexibility for industrial facilities, as well as other metrics that they identify that are relevant to their particular system. So things like reducing unplanned downtime, reducing GHG emissions, reducing operating expenses, reducing peak loads, or increasing productivity. So that is the overview of the topic. I'm happy to have any questions or to move on to the next subtopic.
Okay. There is a question for 12A. I want to make sure that the research plan fall within line with what the topic author is looking for. I'm going to be researching and trying to develop different type of power generator that does not put out UN burned hydrocarbon. I don't understand the question.
Yeah, I will say, I will reemphasize what I said, that the focus of this topic is not on hardware development for power generation or energy storage, but is more on the software and control system side.
Thank you. Let me see if there are. There's for 12, but did not indicate which subtopic. I'm going to read it anyway. With innovation, which convert waste heat from a wastewater treatment plant into electricity, be a good match for this is for subtopic D.
That's that's applied for subtopic 12C as well. So
Okay.
whatever innovation that converts waste heat into electricity with the parameters that satisfy the metrics in the FOA, that would be of interest for this topic.
Is topic 12A related to gas burners optimization rather than electrification? Not all dryers / burner can be electrified.
Yeah, so this topic is focused on electrification and specifically on, yes, on flexible electricity use. And I also see, so it looks like Curtis's question here was mislabeled on the topic. He sent a separate question that corrected the topic label. He asked, will tech that helps decarbonize industrial oil and gas equipment be considered for this topic? There are no restrictions on the application area that are indicated in the topic.
Thank you. There is also 12A, may the flexible industrial process itself be the provision of energy, or must it be something else?
My guess of what this question means is that it should be something else. So when we talk about needing to incorporate a flexible industrial process, we're talking about the actual use of energy by the industrial facility. But that said, you know, certainly the letter of intent phase, we can provide some clarification on whether the concept is in scope or not.
Okay, this question is for 12B. Gas separation focus on CO2 only, or other gases come into interest, H2 and H3?
I would suggest to present the subtopic B first, and after that answering the questions.
Sorry.
So if you don't have any other for 12A, So we can give the floor to David Forrest, who is a topic manager for the 12B energy efficient gas separation.
Oh, okay. There is one for 12A. Curious of clarification around which types of facilities are within scope. We developed grid interactive real-time optimization software for district energy facilities. These facilities serve a variety of end users in the US, including manufacturers, healthcare facilities, higher education, etc., that are not exclusively manufacturers. Would our software be in scope for this subtopic?
Yes, so I would say that that application area sounds like it is in scope, and in general, applicants should, just make the case that their technology is relevant to manufacturing processes in the manufacturing sector.
Okay, so let's move to the next subtopic.
David Forrest is a topic manager for the topic C5812B, energy efficient gas separation.
Okay.
David?
Yeah, thanks, Yaroslav. This is David Forrest. So this subtopic is specifically focused on thin, high precision membranes for gas separations. And there are membranes that can do gas separations. This is true, but most of these approaches rely on a very tortuous path of the gases or even liquids, and as a result, you need a lot of pressure on one side of the membrane, and thus there's an energy penalty for that, and a carbon penalty for that, for the need for high pressure. But in the past decade or so, there have been some significant advances in the ability to make atomically precise pores, that is, pores that are essentially molecules, and you can make these identical to each other. So if you have an array of atomically precise pores where they're all exactly the same size, then you can make your membrane very, very thin with almost no resistance to flow, and do high precision separations based on size or other characteristics of those membranes. And we talk about some examples in the references there. In addition to those significant advances in the ability to make membranes, there are some membranes that are not exactly atomically precise, but pretty close to it, and also giving you the ability to make membranes or membrane coatings that are nanometer scale. And so once again, you get that big improvement in energy efficiency, high permeance, good flow through, and the pressure drops are not as significant. And so both of these types of innovations, and there may be others out there, so we're looking, would naturally lead to the metrics that we're talking about here: 50% improvement in selectivity, 50% improvement in permeance, and would be also naturally impactful in terms of energy efficiency, which is what we're really looking for. Appreciated the question about what kinds of gases are in scope. Wide range. We give a number of examples in the topic description. Separation of air into raw components, separation of helium from natural gas, separation of water from air, but any gases that would be impactful and relevant to industrial processes would benefit from this type of technology. And so that's That's what we're looking at for. And of course, all the usual suspects when you're doing membrane development. You know, you've got to have good resistance to fouling, good chemical stability in whatever environment you're doing the separation. You've got to have great durability, and you have to worry about your substrate material, and of course, you know, the cost of the system itself and the cost of operation. So all that needs to be included in any narrative that would be responding to this subtopic. So I'll go ahead and see if we have any questions.
For subtopic B.
Mhm.
Okay, let me see if there's anything. Subtopic B12.
Gas separations.
Will HVAC filter be something of interest?
If it is significantly improving the permeance and selectivity, I guess. I mean, what we're really looking for though is separations. So so there needs to be some value to the things that you're separating. So if it were okay, so if it were a filter, an HVAC filter that took water out of air, right? That would be impactful because then you don't cool down that water, and there's a lot of energy that goes into condensing water out of air in HVAC systems that you would successfully avoid if you could separate out the water molecules from the air molecules, and a whole range of impacts would fall out from that kind of high precision separation, because all of a sudden you would have super dry gas that could be applied in paint drying, for instance, energy intensive process. Air conditioning, obviously, a very big, even hair dryers, right? It sounds crazy, but if you crunch the numbers, there are billions of dollars spent in electricity for heating for hair dryers on a daily basis, and dry, cooler air would save energy and would actually decarbonize.
Thank you.
Sure.
There's a question for topic 12. The person is saying only Yaroslav is designated as point of contact for topic 12. Are there the other managers? How can they get in touch with the other managers?
Yeah, I put my point of contact before today's webinar, just to avoid kind of polluting a lot of inboxes, because we start getting after the topics were published, we start getting enormous amount of the requests and questions. So I believe many questions will be answered today, but if you still have questions, you can send the request to me and I will put you in contact the appropriate topic manager, with David, with Zach, with others. I would like to oversee the entire topic. So
Okay.
It's not a problem. We put you in contact. Just send me a request.
Thank you so much. Thank you. So going back to the same question, to add on to the HVAC question, the focus will be on providing high quality indoor air in a building at significant low energy demand.
Sure, as long as you meet the metrics, it's and you're doing a separation that's that's in scope.
Thank you so much. Let's move to the next subtopic.
I'm sorry, I just lost my mouse to unmute
No, it's
myself.
okay. Go.
So next subtopic, I'm just topic manager. It's innovations in heat exchange processes, equipment, and integration approaches for deep waste heat recovery. So this topic, as many of you know, that generally industrial energy losses to the environment, it's about 40 to 60%. It's an enormous amount of energy. So this topic is mostly focused on the transformative technologies or innovations or concepts that can help industrial sector to recover and reuse that energy losses. For example, for low temperature waste energy under 450 degrees Fahrenheit, just only for manufacturing segment, not wider industrial, just only for manufacturing segment, estimated annual potential of the available waste energy, probably 1 to 2 quads with reference temperature close to ambient. So there are plenty of applications over there, ranging from boilers and dryers to ovens and engines and industrial processes for the food and beverage and many others, has exhaust which are lost to the environment. And this topic is kind of opens but not limited to any type of innovations regarding the heat transfer enhancement techniques, thermal driven waste heat to power technologies, novel type of heat exchange equipment, any integration approaches, for example, recombination in some industrial line, for example, losses in the one part of the industrial process may be the valid energy input for another part of the same process. So primarily focus on the low temperature waste energy and non-metallic thermal energy exchangers, which resolve some specific issues of the corrosion, erosion on the many industrial sites. I would say that if your concept, idea, technology may satisfy the metrics in table 2, it's eligible. That's in 2 words. If you have any specific questions, I would be happy to answer.
Okay, for 12C, there is a question. Must a proposed concept include waste heat recovery from an application that has a vapor waste heat stream source versus a liquid waste heat stream?
It's any waste with a product, with a gaseous waste, with a liquid waste, with a solid waste heat, whatever energy wasted, we would like to capture it, but not in the incremental way. We would like to deeply recover it and reuse.
Thank you. Will you consider an innovative specific heat exchanger software to optimize the operation and make it more cost effective in the deep waste heat process?
That word more, we are not looking for the incremental improvements. We are looking for the disruptive innovations, because if you just have the, let's say, ancient 100 years old invented shell and tube heat exchangers, you may optimize it to the full capacity, but that heat exchanger will not be able to achieve the metrics parameters.
Will the development of energy conversion device for directly converting waste heat to power electricity be responsive to this subtopic?
Yeah. If it meet the metrics.
Okay. Is the hardware applicable for 12C?
Yeah, hardware is applicable, and concept and lab scale demonstrations and bench scale demonstrations prove the concept. That's what we are offering, that opportunity to the small businesses, just to start some innovation in their way to the higher level TRL technology that could be funded by standard funding opportunity announcement of our office.
Thank you. Let's move to the next subtopic. Renewable hybridization.
Yeah, it's also my topic, and as you know, industrial sector uses heat for wide variety of the applications, and it's accounted for over 20, probably 25 quads of BTUs, which represent 1/3 of the nation delivered energy supply. So we're looking for the innovation in coupling the renewable sources towards to the industrial application and industrial systems, just to boost up their efficiency and reduce the carbon footprint. So we are looking for the concept which can provide reduction of energy consumption over 30% as a minimum, but over 50% as a stretch target, and relatively low simple payback with not more than 10 years, preferably 5 years or better.
Okay. Let me see if there are any questions. Yes, would solar thermal with TES and direct heat source that would serve plant combustion or electric heating apply to this topic?
I would say that solar thermal, yes, but electric heating, maybe, but it depends on what innovations you put into it. Because solar thermal and TES require significant capital budgets to be implemented. And I don't know how, with today's cost of the fuel and the electricity, it would be challenging to meet the required payback. But anyway, it's qualified for this subtopic.
With innovations which convert waste heat from a wastewater treatment plant in electricity be a good match for this subtopic?
Yes, as well, because that's a just kind of device which is converting waste heat into electricity. The question is with what efficiency and at what conditions.
Okay, thank you so much. There are some questions in the Q&A box. If you can type answers. Due to the time, we have to move to the next topic. So thank you so much for your time.
Thank you, Zina. And I would like to let to know all the attendees that if you have any questions, just shoot it my way.
Thank you so much.
Thank you.
So we'll go to topic 13, and we will start with Bo. Are you online?
Hi, actually, I'm going to be presenting instead of Bo. This is Maxim.
Go ahead. Thank you so much.
Yeah. So hi, everyone. My name is Maxim Kostlov, and Bo was unable to attend today, which is why I'm presenting in his place. So the title of the topic is Sustainable Biomass Conversion to Bio-Based Materials. And this is to support the goal that the Bioenergy Technologies Office has to enable by 2030 the production of more than 10 renewable chemicals and materials that have at least 70% greenhouse gas reduction in comparison to petroleum-based counterparts, incumbents. And so the general process of converting renewable feedstocks to materials involves, selection of a feedstock, transportation, pre-processing, and then once you have this material that's been transported and pre-processed, it undergoes various forms of fractionation, deconstruction, conversion to basically make molecules and chemicals that can then be further upgraded or converted to materials. So in terms of feedstocks that we consider acceptable for this, so this call is intended to essentially support this goal of producing renewable chemicals that have a severely reduced green carbon intensity compared to petroleum-based counterparts. So the acceptable feedstocks for this call include lignocellulose, so that's agricultural and forestry residues, various organic waste streams, municipal solid waste, as well as micro and macro algae. So that includes seaweeds. And then in terms of the materials that we're interested in seeing in these applications, the general categories, although these aren't exclusive, include carbon fibers, composites, foams, textiles, polycarbonates, epoxies and resins, adhesives, as well as filters and membranes. And then in terms of what we think of as conversion technologies, that includes everything that would happen to the feedstock after it has been transported and pre-processed. So that would include fractionation technologies, fermentation, biochemical and chemical conversion technologies. And importantly, we're also interested in anything that involves characterization of the original feedstock or intermediate mixtures. So doing this in high throughput manner that's cost effective. And the same goes for purification and separation. So these are processes that can be done at the lab scale with high expense, but not always done quickly with high throughput and cost effectively for commercialization. So then in terms of, so we also encourage applicants to establish partnerships with end users of whatever material they might be working to create to test the performance of that material or the properties of that material. And we also encourage improvements and refinements in techno-economic analysis or LCA models. And then as far as what's not of interest for this call are technologies that are upstream of conversion. So that includes feedstock cultivation, transportation, and pre-processing. We also do not encourage applications for the production of pharmaceuticals, nutraceuticals, biomaterials for medical devices, or feed proteins. And then in terms of feedstocks, we do not encourage applications that use CO2, sugars, or starch as sole feedstocks. And I think that's about it.
Thank you. I don't see any question for 13A, so we can move to the next subtopic.
Yeah, hi everybody. My name is Ben Simon. I'm a technology manager within the Bioenergy Technologies Office, and I'm the topic lead for the alternative uses of commercial equipment, or ACE topic. The overarching goal of this topic is to engage and bring in new players within the equipment manufacturing or equipment operating markets into the bioeconomy to develop and demonstrate new biomass pre-processing technologies. Pre-processing is a general term used for the initial handling of biomass feedstocks to put it in a state that enables downstream conversion that we just heard Maxim talk about. For example, corn seed is separated from the cob and either wet or dry ground into a powder or mash before fermentation into ethanol. As the Bioenergy Technologies Office, we seek to develop new biofuels, bioproducts, and biointermediates from emerging biomass feedstocks, such as energy crops, agricultural residues like corn stover, municipal solid waste, and algae. There's a need to engage with small business innovators to develop creative ways to utilize existing equipment and alternative settings to pre-process these emerging feedstocks. For example, maybe a separator that's used in the mining industry can be shown to effectively size reduce and dry corn stover for downstream conversion. The feedstocks of interest for this topic include energy crops, cellulosic materials such as agricultural residues, organic wet waste such as food waste or sewer sludge, algae, construction and demolition debris, and oil seeds. Woody biomass like sawmill debris or forest thinnings and other non-biomass based feedstocks are not of interest for this topic due to their mature industries. Targeted pre-processing metrics could include, but are not limited to, size reduction, particle size distribution, contaminant removal such as inorganics, reducing the moisture content, densification and extraction of oils, starches, etc. Phase 1 applicants should address 3 main metrics in their application as part of their project scope. Identify at least 1 pre-processing unit operation or piece of equipment of interest. Identify at least 2 feedstocks to pre-process, and identify at least 3 pre-processing metrics that the unit operation could deliver. The goal for phase 1 would be an economic feasibility study to determine the costs for running and any retrofit costs associated with the equipment, as well as identification of downstream user specifications. Expected goals for phase 2, the project team would demonstrate operation of the equipment to deliver conversion-ready feedstocks, meeting those downstream user specifications you identified in phase 1. With that, I thank you for your time. Look forward to reviewing your innovations and happy to address any questions you have. My email can be found here and at the end of the topic. And with that, I'll pass it off.
Thank you so much. I don't see any questions. So there is for 13A or B is a novel conversion of biomass, renewable and fertilizers or zero carbon fuel a good fit?
I guess I'll take that. I would say that we consider fuels to be a separate category than materials. And therefore, I would say that this is not responsive to the topic.
Okay, thank you. Would technologies that minimally process biomass into a composite for building applications without breaking down the biomass via fractionation or fermentation or a chemical process be in scope?
I think for that one, we would probably need to see the application itself. So I would encourage a letter of intent in that category so that we can provide proper feedback.
Okay. I don't see other questions for topic 13. So thank you so much for your time. We will move to topic 14. Janelle, are you online?
Yep, so sorry about that. Just got frozen for a second.
That's okay. Go ahead. Thank you.
Yep. Hi, everyone. I'm Janelle Schwartzberg. I'm a contractor to the Department of Energy, and I'm providing contractor support to BTO's SBIR and STTR program. Unfortunately, all the BTO topic leads are unavailable today, so I'll be introducing their topics on their behalf. I can pass along any questions from the Q&A today to them, but you can also find their contacts on this screen, and feel free to send any technical questions to the topic lead that's listed. This year, BTO's topic consists of the 6 subtopics listed on the slide, and some of the subtopics also include further subtopics. Starting off, we'll start with the Windows topic, which is led by Mark. It has 2 subtopics. The highly insulating Windows subtopic will explore, sorry, one second. We'll explore core technologies, materials, and processes that contribute to major improvement in the cost-effective improvement in window thermal performance. So the topic description has examples, but is by no means an exhaustive list. The dynamic solar control subtopic will explore the control function with low-cost devices that are extremely easy to install. The topic description defines the ultimate solution with completely wireless communications and power, but solutions don't have to be 100% wireless. Other proposals are also welcome. Ideally, the communication should be completely wireless, but like the power and for controls can have a little bit of wires involved. The solution should be controls oriented and not materials. For both of these subtopics, we strongly recommend reading through the Pathway to Zero Energy Windows RDO, which includes extensive performance metrics. I can throw the link in the chat momentarily. For partnering, teams are encouraged to identify which partners would help improve their team. Not limiting, but collaborating with national labs can be helpful. For example, LBNL, which is the core Windows lab, and NREL can offer technical assistance for dynamic solar controls. Phase 1 should prove the viability, which could be explored further in phase 2. And proposals can be for advanced technology or significant cost reduction. The solutions can be broad or very specific, and this is open to both residential and commercial solutions. Moving on, the affordable thermal energy storage systems, advanced air leakage detection and air sealing technologies, and insulation innovations are all led by Sven. Each topic description has examples of areas of interest, but they are by no means an exhaustive list. For affordable TES systems, some examples of innovations could be space conditioning solutions for combined heating and cooling, easy to install insulation solutions for enhanced thermal comfort, energy efficiency, and resilience, especially during peak temperatures, and easily replacing existing gas hot water heaters with new hot water solutions. For the advanced air leakage detection and air sealing technologies, some examples of innovations of interest are air leakage detection and measurement, and productivity tools to seal air leakage quickly and accurately. For the insulation innovations subtopic, some innovations of interest are low-cost insulation materials over R8 at $1 or less per square foot, very high R value, or innovations that help productivity, delivery mechanism, and quickly installing insulation systems. For all three of those subtopics, so affordable TES, advanced air leakage detection, air sealing technologies, and insulation innovations, the topic descriptions have critical metrics in terms of performance and cost. As you can see, affordability is a main concern, with cost targets included in the topic description. The topics focus on getting new ideas commercialized quickly rather than early stage R&D. Specifically for the insulation innovation subtopic, we recommend referring to the opaque envelope research report for references and prior state of the art. I can send that link out momentarily as well. The expected partners for all these three of those topics, teams should understand their capabilities to identify which additional stakeholders will be important in getting the solution to market. So like understanding the market, manufacturing, bringing to commercialization, just whatever the team is lacking, and should find partners that will help accomplish that. The partnering needs could look different for every team. And for phase 1, some sort of prototype should be produced, and phase 2 should produce a commercialized product. Then for the solid state lighting technologies, the topic lead for that one will be Wyatt. The lighting topic this year consists of 3 subtopics. Advanced lighting fixtures is the traditional lighting subtopic, and 2 new subtopics were added to highlight emerging technology areas that lighting can be more involved in, including agriculture and germicidal ultraviolet technologies. The lighting topic is intentionally broad to encourage all small businesses in the field to consider applying. The germicidal ultraviolet technologies and controlled indoor agricultural subtopics were added this year to encourage an even broader applicant pool and to highlight new opportunities in lighting and radiometric innovations. The DOE Solid State Lighting R&D Opportunities document is the best resource to learn about the specific innovations DOE is seeking. I will send out that RDO as well. For critical metrics, all proposals should have energy saving component defined relative to the state-of-the-art existing products, not relative to especially inefficient incumbents. Proposals should attempt to define technical potential energy savings based on estimation of potential installed stock. Efficiency can be defined by the applicant to be more than just lumens per watt, including lighting application efficiency, including optical and spectral efficiency, or using relevant action spectra for the application in question. Phase 1 should show promising proof of concept and market potential that can be further explored in phase 2. And we received a question if non-LED solutions would be considered in the germicidal ultraviolet subtopic, since it does state Gov LED. So non-LED solutions may be more appropriate for the germicidal ultraviolet topic, given the effectiveness and efficiency of alternative radiation sources in that wavelength region, and we would not disqualify an application based on the lamp type for the germicidal ultraviolet subtopic. And then lastly, we have the heat pumps and heat pump water heaters subtopic led by Alex. This subtopic covers heat pump and heat pump water heaters. There are 4 submission options. So the first subtopic within that is heat pump systems for cold climates, which focuses on improving systems designed for cold climates, including dual fuel systems and their controls. And solutions may include the integration of existing systems. The cost compression of heat pumps and heat pump water heater systems focuses on reducing the system costs at system design, equipment distribution, and or installation. This is the most broad subtopic, and software submissions are encouraged. The building integration of heat pumps and heat pump water systems focuses on the systems integration with the building. And finally, the heat pump water heat ready outdoor enclosure subtopic focuses on a technology that allows for the outdoor installation of 120 volt heat pump water heaters. The applicable innovations are fairly broad for this subtopic. Technologies of interest span both hardware improvements as well as software solutions, depending on the proposed solution. The topic is focused on the residential space, and the subtopic description provides more details on which might be applicable. For critical metrics, projects will be judged on a variety of things, including but not limited to cost, emissions, size, power reduction, the innovation will receive, market size and scalability, predicted efficiency improvements, and performer qualifications. Successful projects will also provide information into how their technology will positively impact underserved communities and low-income occupants. Applicability to multifamily and manufacturing housing is also encouraged, although not required. Successful teams will have partners for their proposed work. Who that is will depend on the submission, but could range from R&D organizations, manufacturers, utilities, distributors, contractor organizations, local organizations, or other team needs. All subtopics are focused on system level rather than component level, especially for subtopics 2 and 3. And yeah, pretty much everything. If there's any specific questions, I can try to address them. But anything I can't answer, I can forward on to the topic leads since they have more insight.
Thank you so much. There are two questions. Does it have to be both detection and sealing? There is no subtopic number included, just says 14, topic 14.
If anyone has a specific subtopic for that, please let me know. But I can pass that on to the topic leads and get a response, just so I don't give anyone any misinformation.
Thank you. 14F, if a technology eliminates the need for fossil fuel backup system in very cold climates, would a proposal be considered responsive if it achieves this and thus avoids the complexity of coexisting with a carbon intensive legacy system?
I would reach out to the topic lead for to be more sure, but I do think that that could be in the scope for this topic area. I don't think like the dual fuel is required. It's just an option.
Thank you so much. For all other questions related to topic 14, please reach out to the topic managers listed in the topic document, and also the emails are on the screen. Thank you so much. Thank you, Janelle. We will move to the next topic, topic 15. Michael?
Yeah, hi. Thank you, Zena. I'm Mike Weathers. I'm a hydrothermal technology manager within the Geothermal Technology Office. You can think of hydrothermal resources as conventional geothermal resources that we have to go out and do exploration for and try to discover them. And a little background on this R&D topic. GTO, we've long run an R&D program focused on identifying hidden resources, so-called blind systems. So these are resources that don't have anything on the surface to let you know they're there. So we have to rely on pretty advanced methods to try and locate them. In the past few years, we've had some success, particularly in the Great Basin region of the US. A few examples: geothermal play fairway analysis, which we've used to, it's kind of a regional scale reconnaissance to high grade areas for a further look. We've done some work on so-called large N geophysical arrays. So these are attempts to image resources using large number of sensor nodes, think thousands of sensors. And lately we've been doing quite a bit of helicopter-based airborne sensing. So that's looking for certain hydrothermal features that show up well in resistivity models. Something we haven't done a ton of lately, but we hope to, because we know it's important, is more heat flow measurements and looking directly at temperature measurements in the shallow subsurface, which actually could be anything from super shallow, a couple meters deep, all the way up to full-on temperature gradient drilling. And all of this work is ongoing, and hopefully we can do a lot more of this in the future, but most of those projects are focused on what's actually done with the data once it's collected, and not how we get it. So they've focused on how to interpret it and how to use it to create a strategy for resource development. But the innovations we're looking for on this R&D topic are actually intended to accelerate just the collection of the data that we already know are so valuable. So how do we make these surveys out in the field cheaper, faster, and more efficient, more easier to permit, perhaps combine multiple methods into one field session that are typically done separately, that type of thing. And there's a bulleted list of data types in the solicitation topic that we know GTO supported researchers have found particularly useful in the recent past, and some of them industry are starting to adopt more and more. There are probably many others we haven't thought of, so that list is not exhaustive. It's just to kind of illustrate where we're coming from. Also note that they're all very site specific, and that no method is universal, so everything has to be kind of tailored to the actual location that you're investigating. But some of these methods, we found that they come with a really high price tag. It can even approach the cost of drilling an exploration well. And at some point, a developer has to decide when to forego additional data collection and get started drilling. So hopefully the projects that come out of this topic are going to develop methods that allow the explorationist to get all the data they need pre-drilling to properly mitigate risk without dipping too much into their drilling budget. And how do we do that? Well, I don't know. Hopefully people in the audience have some ideas, but we have a kind of a bulleted list in the topic, that a few examples just to illustrate. So one that seems kind of hot right now is the use of autonomous vehicles. So that includes UAVs, could be aerial, could be tracked vehicles, even others. I've heard airships are even making a comeback. So this approach would let a field team cover a much larger area than they otherwise could on foot or on ATV, how it's typically done these days. Perhaps someone can figure out how to get approval from the FAA for autonomous aerial surveys that are beyond the operator's line of sight. So this is a huge limitation, especially for some of the big Western states, think Nevada or Alaska. How can we survey a vast area if we have to stay within arm's reach of the aircraft? It's difficult. And automation isn't just about airborne work. It could be, robotics, we think, could be used to deploy or retrieve sensor nodes, think seismic or magnetotelluric sensors, or maybe could be used to even place them in the shallow subsurface like temperature probes. Another one we've listed as an example is possibly improvements in instrumentation. So for example, the new quantum sensors, they're super lightweight, very sensitive, might be small enough to deploy on a UAV, whereas current systems are pretty heavy and have to be deployed on an actual airplane with the pilot. What we're not really interested in is projects that are focused on demonstrating some application of the data that's collected. So we're already supporting a lot of that work. We know a lot of these are very valuable data sets. So what we're hoping to do is with these projects, get operational improvements or technology improvements that really bring down the costs. So for critical metrics, think in terms of cost per mile, cost per surface area, or cost per discrete measurement, those types of metrics, and it varies for every different kind of survey. So the specific ones you're thinking about, you would need to try to show some kind of an improvement. No requirements on expected partners, but obviously teaming up with a geothermal developer or another potential customer would be pretty valuable. And our expectations for phase 1 versus phase 2, we're not being super prescriptive here, but it seems sensible to kind of prove things on the bench in phase 1 and then hopefully get an actual field demo done in phase 2. But we could be open to other suggestions if there are any. And then lastly, I'll point to the reference in the solicitation. We list a paper from one of the researchers we've supported, we call it the Ingenious project. They're developing a pretty complete workflow for finding hidden geothermal resources in the Great Basin. And I encourage you guys to check out their Subsurface Data Explorer. You'll see in there that they have identified many interesting areas to study, many more than they can actually do in their project. And you can think of those as prospects or fairways that could be a good location for testing the technology that you're developing. So check that website out if you have time. Yeah, and that's my description. I can take some questions now if there are any.
There is one question. Interested in drilling an exploratory pilot well to test geothermal gradient in tight thermal rockets.
Yes, so drilling, it's definitely important, and it's an important source of data. We wouldn't be interested in supporting funding a discovery well for a specific resource. Again, we're focused on the operational improvements that will in the future allow us to do many cheaper gradient wells, if that makes sense. So it's the data collection, not getting the data to do something with it. It's how can we accelerate data collection?
How do you feel about transitional models of geothermal generation within the earth that can be extrapolated to surface proximate results? Looks like you're only interested in top-down approach, but if you are interested in bottom-up, that would be helpful to know.
If by top-down you mean, well, we're focused on data collection in the field, so modeling is not really of interest. We're focused on field data collection, if that answers the question.
Okay. I would be addressing geothermal exploration activities as specifically described in the topic. However, would additional utilities related to monitoring of environmentally sensitive hot springs or monitoring existing geothermal infrastructure be worth describing in the proposal?
To the extent that those data collection are valuable for exploration as well. And there probably is some overlap, so we'd probably need to know more about that specific application to get you a good answer there. I suggest you send us an email on that one.
Okay, our vision is that the future of utility large-scale solar, wind turbine, and energy storage plants is airborne by fleet of drones. Are you interested in this?
No, possibly some of the other offices would be, where this is focused specifically on geothermal resources.
Would a UVA-based beyond line of sight sensing demonstration be of interest?
Yes, for sure. As long as it's collecting data that's of value for geothermal exploration.
Okay. I guess massive data generation and analysis by synchronized UVA fleet, hives, aerial inspection is critical to maximize the clean energy generation outcome. I think it's a the person is adding to the previous question.
Okay, yeah, we may have to have a conversation on that, because if it's directed at assessing other resources, it's not of interest. But if it can be tied directly to geothermal, then for sure we're in business.
Thank you. No further questions for
Thank you.
Topic 15, geothermal. Thank you so much. We'll move to the next topic. Topic 16. Will, are you online?
I am. Can you hear me?
Yes, go ahead.
All right. Well, so I'll jump into it real quick here for 16A novel applications for stationary fuel cells. With this topic, we're really looking to grow potential new markets for fuel cells in general, but with a specific emphasis on the types of systems that are currently being manufactured, mostly fuel cell stacks that can be used in medium and heavy duty vehicles. So this is a stationary topic, meaning we're looking to take what can sometimes be installed in transportation type systems and move them to a stationary application. The power level and the format is open. It's technically fuel cell technology agnostic, but there's obviously an interest in using and leaning into some of the new manufacturing efforts in the space to continue to build demand for fuel cell systems. This applications could include primary or backup power. You could think about some long duration energy storage applications as well, and combined heat and power. Other areas that might be interesting are applications that support electric vehicle charging and hydrogen infrastructure operation and maintenance. So one example is corrosion protection for pipelines using fuel cell systems. Of additional interest are some subsystems that capture waste heat and water and turn those into useful byproducts. It's relatively open in that respect, but we are obviously interested in systems that make sense and adhere to the mass and energy conservation. So I'm actually going to leave it there and see if there are any questions. I know we're relatively short on time.
Yes, we have one question for 16A. Is the subtopic only concerning ending product application, or with a proposal on a specific subcomponents of a stationary device, for example, innovation on the catalyst or MEA be within scope?
Okay, that is an excellent question. We are looking, actually an excellent question. We're really looking to take existing stacks and put them into systems that are somewhat novel. So we have a lot of work going on elsewhere in the program that is developing catalyst, MEA, stack subcomponents, membrane work that would not be of interest for this particular topic. This should be thought of more as a basic process flow, material and energy balance for a novel application, potentially with a bench scale demonstration for phase 1. Phase 2 would obviously be a much larger demonstration. But primarily we're interested in the repurposing of existing stacks into novel applications. So we would not be interested in fundamental work on stack components like catalysts, MEAs, bipolar plates, that sort of thing. That would not be of interest.
Thank you so much. No further questions. We'll move to the next subtopic, and we have Abe. Abe,
hello, can you guys hear me?
Yes, I can hear you.
Yeah,
Go ahead.
can you guys hear me? Yes. Okay, hi, I'm Abe. I am filling in for Kevin, who is out and couldn't make it today. I'll be discussing the next 2 subtopics, that's B and C. Let's go through 16B first, which is novel materials for use in liquid hydrogen. So as far as we go, what we are interested in here is looking at new novel materials or existing materials where we can improve the performance. That would be primarily for looking at fields in two environments. One is in dynamic or in static. Dynamic would be in pumps, and it would be in static would be in phase seals, pressure regulators. One of the key things that we want to emphasize is the ability to be able to work at ultra low temperatures, such as 20 Kelvin, and up to ambient temperatures. One of the key issues is most of the materials have a glass transition temperature that's way above the 20 Kelvin region. So we need to look at materials that can perform in this area and temperature regime. Other area that's of interest is composite materials that could be used for components of a vessel for liquid hydrogen storage. One of the key advantages of liquid hydrogen storage is its higher density and also ability to work at lower pressure. So we could have something that's lightweight and has ability to hold more hydrogen by gravimetric capacity or volumetric capacity too. Again, like looking at seals, the key parameter would be ability to handle temperatures from 20 Kelvin to ambient. In some cases, we're also looking at ability to dispense as much as 10 kilograms of hydrogen per minute. And in high pressure storage, we could look at pressures where we could easily see 20 bar, or if it's a high pressure filling station, as high as 700 bar. Low cost and ability to perform well under these conditions is critical. And also looking at applications where you will undergo numerous or large pressure cycles. So you will be working at very low pressures, low temperatures to high pressures, relatively higher temperatures. As far as support, there is some ability to consult with HMAT, which is a consortium, limited ability to consult with High Blend. However, there are no funds to pay them. As far as we're moving on to phase 1 versus phase 2, we would like to see a prototype demonstration if phase 1 is successful in relevant conditions, and also ability to perform for a targeted application. I can answer any questions on 16B or go through 16C and then come back to 16B.
Please go ahead. I don't see any questions.
Okay. As far as 16C is, we are going to are interested in looking at novel concepts for hydrogen infrastructure and storage. And here we would like to see, are there any ways to understand how we can incorporate novel concepts such as 3D manufacturing of complex shapes and components to be able to design conformable tanks or systems that are more amenable to be on board or also for static applications. This allows us some design flexibility. There is no interest in looking at carriers, although that was mentioned in there. So proposals that would be focusing on carrier development or catalysis are not the focus of this call. And use of thermoplastic resins versus thermoset resins is something that's of interest. Again, the same temperature criteria remains. However, in this case, we could look at something up to 100 degrees Celsius and ambient pressure to almost 1000 bar would be something of interest. As far as collaborating with national labs consortiums, again, same thing. HMAT is available on a limited basis. High blend might be even more limited. And we would like to see cost and rate of manufacturing and storage components and cost and system level storage density of stored hydrogen as a key metric to be focused during the call, in the call. Any questions I can answer right now, or I can pass it on to Kevin and he can answer them.
Okay, there are questions. Are novel manufacture methods in scope? We have some methods that may scale better for high pressure than conventional manufacturing. And then are there any national labs that we can partner with in phase 2?
I will take the second one. Yes, we can partner with national labs in phase 2. I will pass on the questions to Kevin and he can give a more reliable answer, but that's something that we can work with some of the consortiums through HMAT for sure, and also with High Blend.
Okay. Are you looking for transforming H2 into other moleculars for easier transportation like ammonia? Is this considered a carrier with your earlier comments?
This is considered, ammonia is considered as one of the potential carriers in addition to formic acid and some organics. So that's not of interest here. However, if you have an application where a carrier could be used for like understanding the technology limitations that are listed here, such as designing a carrier container or understanding liquid hydrogen, then that's fine. But developing ideas for how to make a carrier better is not the focus here.
Okay, thank you so
much. And I think
much.
there was one more question about innovative manufacturing techniques. That is of interest, and that is primarily to understand if there can be ways to control design flexibility. Yeah, that's all I have. Thank you.
Thank you so much. Thank you. We'll move to the next, oops, sorry.
Hello, everyone. Ben Gould here from Hydrogen Fuel Cell Technology Office to introduce the next topic as we get the slides set. It is power takeoff units to support medium duty trucks. I work in the systems development integration team at the Hydrogen Fuel Cell Technology Office, so we're focused on more high TRL developments. This supports our overall goal of decarbonizing transportation. We have 2 flagship programs in medium duty trucks to develop fuel cell trucks, known as the Super Truck programs. You can view them at the DOE AMR archive. It's a great resource to look at, understand sort of what we're looking for. We're looking for power takeoff units to marry with these vehicle developments. So medium duty trucks are often work vehicles, and they often run implements at construction sites or out in the course of their operations like snowplows. Mechanical power takeoff units are a very mature, robust technology, but ones for electric architectures are nascent. So we're looking to beef that up. What's important to us is having a device that is, cost effective, reliable, manufacturable, and integrates with, the automotive market. So we don't want bespoke controls. We want something that really dovetails into what automotives expect. Thermal management is also very important to us. How do you manage the heat with these units when they're during operation? Let's see. Yeah, that's pretty much it. We think, in terms of what would be good teaming, we want to make sure there's, strong pull from automotive partners, and we expect a design and proof of concept, demonstrations at the bench level in phase 1. In phase 2, we'd be looking for actually development of a prototype. And with that, I'd like to open it to any questions.
I don't see any questions, so we can move to the next subtopic. Eric, thank you, Ben.
Yep.
Hi, I'm Eric White. Can you hear me?
Yes, go ahead.
Hi, I'm an engineer in the fuel cell group within the Hydrogen and Fuel Cell Technology Office. And this subtopic is titled High Temperature Membranes and Membrane Electrode Assemblies for Fuel Cell Operation. Our group is focused on making fuel cell propulsion systems primarily for medium and heavy duty vehicles right now, but we have longer range goals for stationary electric power generation, including primary power and backup power, as well as combined heat and power. So conventional fuel cells typically run at temperatures below 90 C and high relative humidities. But there are real cost advantages if we can extend those operating conditions. So this topic solicits new ionomers and membranes that are integrated into membrane electrode assemblies for high temperature PEM fuel cells. We'd encourage MEAs that are suitable for heavy duty applications. And we seek high temperature PEMs that have high proton conductivity in a temperature range between 120 degrees and 200 degrees Celsius over a wide range of relative humidities. They would be highly durable and be compatible with existing fuel cell architectures. That is the main thrust of this topic, and I'd be happy to take questions.
Let me see if there are any questions for. Yeah, would a proposal focus more on improvement of the catalyst, for example, endurance, durability, and cost tailored for the harsh HT PEM operating condition rather than innovation of the membrane or the assemble themselves be responsive to this subtopic?
I'd say a proposal that focuses only on catalyst development probably would not be responsive. It would, the limiting factor really is the membrane and ionomer materials. But I would like to emphasize that we're looking for new ionomers that are demonstrated in membrane electrode assemblies, which would include catalyst materials. So I hope that answers the question.
Thank you so much. No further questions. We can move to the next subtopic F.
Hi.
Hi, go ahead.
Hi, I'm Anne Marie. I work in the hydrogen production sub-team of HFTO, and my topic is advanced proton exchange membrane electrolyzer bipolar plates. And so for this topic, we're looking for applications that develop platinum group metal free coatings for bipolar plates and or developed bipolar plates that use materials that are less expensive than titanium, which is currently required for the conditions that proton exchange membrane electrolyzers operate at today, which include low pH, oxidizing voltages, and elevated temperatures. bipolar plates are really important for the operation of electrolyzers because they enable product separation, wattage management, and electronic conductivity. However, these conditions enable corrosion, and so these titanium plates are often also coated with precious metals such as gold or platinum. So we want to lower the cost of manufacturing bipolar plates by developing or other materials that are of lower cost. For a phase 1, we expect that the applicants will develop the proposed technology and be able to demonstrate its capability to be integrated into a PEM electrolyzer system. And for a further phase 2, being able to test it in a PEM electrolyzer. I'll leave it at that.
Thank you. I don't see any, oh, there is a question. Is the subtopic looking for strictly PGM-free material, or would technology to significantly reduce the required PGM loading be responsive?
I think that if you had a strong justification for why this technology would enable significant cost reductions for the manufacture of bipolar plates, then that would be responsive to this topic.
Thank you so much. I don't see any other questions, so we can move to the next subtopic. Elias?
Hello, can you hear me?
Yes, go ahead.
All right, thank you. Good afternoon. My name is Elias Pomeroy, and I'm a scientist on the hydrogen production team within the Hydrogen and Fuel Cell Technology Office. This subtopic is looking to develop new technologies and materials for water electrolysis outside the traditional pathways of liquid alkaline, proton exchange membrane, and alkaline exchange membrane in solid oxide systems. The goal of this subtopic is to provide funding to novel, lower TRL technologies for hydrogen production. This subtopic is pretty broad, including looking for new materials and components such as electrolyte materials, which would enable intermediate temperature operation, specifically between 125 and 450 degrees Celsius. We're also interested in novel system designs, including membraneless electrolyzers or capillary fed systems. These examples are not all inclusive. If you have a new material or a novel system that isn't specifically mentioned, consider applying. Given the broad nature of the subtopic, it might be more helpful to address what is not covered. For this subtopic, systems which don't use electricity to split water into hydrogen and oxygen would be considered non-responsive. Therefore, thermochemical or photochemical water splitting or other systems which don't use electricity to split water are not included in the subtopic. Additionally, the product stream should also not lead to unsafe mixtures of oxygen and hydrogen gas or otherwise create dangerous conditions. A slight mixture might be inevitable, such as the crossover which occurs with PEM or liquid alkaline systems, which is understandable, but the process shouldn't form explosive gas mixtures for obvious safety reasons. Phase 1 applications need to provide details about your technology concepts and the advantages they provide over other electrolyzer technologies. We need to know how your system works and why they're better than existing technologies. Such advantages could include cost, operational capabilities, performance, durability, and or optimization for end users or industries. We need to know how well your system performs, and when providing those estimates, please include performance estimates on a specific energy consumption basis in kilowatt hours for electric per kilogram of hydrogen and kilowatt hours thermal per kilogram of hydrogen. We also need an estimate of the levelized hydrogen cost in dollars per kilogram of hydrogen. These values will enable us to compare your technologies with existing systems as well as other applicants to determine if your proposal is worth considering. We know that these technologies are going to be at a low TRL, so we expect that during phase 1, you'll be developing and or optimizing materials, components, and cell designs on a laboratory scale to confirm your ability to efficiently split water into to produce hydrogen. Thank you for your time, and I look forward to reading your proposals.
Thank you. There is a question, but it just says for 16, I'm going to read it anyway. How likely are fundamental atomic molecular modeling advanced with very low TRLs to be considered responsive?
For this specific project, we're not really looking for modeling. We're really looking for new materials or systems.
Thank you so much. No further questions. We can move to the next topic, topic 17.
Zina, can you hear me?
Yes, go ahead.
Yep, okay. So, good afternoon, everyone. This is George Stefopoulos. I'm a technical advisor for the Solar Energy Technologies Office. Unfortunately, Rob, who is our PM, was not able to attend, so I will be filling in for him. And I will be the one providing an overview of all the 4 subtopics under the solar technologies topic for this year. So quick question here, Zina, would you like to do questions for each subtopic, or would you like me to go through all of them and then I can answer questions?
Let's go through all of them and then we'll take questions at the end.
Okay, that's what I had in mind. Thanks. So first of all, I'm going to mention that as it has happened in previous years, CETO will be having a separate webinar dedicated to the CETO topics, the subtopics. So we will provide a lot more information there. So during this time and in the interest of time as well, I'm going to do a brief introduction to each one of the topics and subtopics, but please look it up and make sure you also register for the CETO topics webinar. The date is going to be Monday, December 4th. So Monday, December 4th at 2 p.m. Eastern time. So I can put the link in the chat so that you find the information and register for that as well. And we'll do a much more thorough discussion on the subtopics during that webinar. Having said that, a couple of high-level comments that apply to all of these subtopics. There is a lot of wording and information in the description, so make sure you read this carefully. There is contact information as you see there. Feel free to email us with any questions. However, as Zina also mentioned at the beginning, keep in mind that we cannot give you very specific feedback if your proposal is a good fit for a subtopic. We can answer technical questions, or we can clarify some aspects of the descriptions, but we cannot tell you yes or no, apply. This is up to you to determine and to make the determination, and also make the case in your letter of intent why you feel what you're proposing is appropriate for each one of these subtopics. In terms of what we're looking for, and this applies kind of like overall to all the subtopics, CETO is viewing these applications as business development activities. So we are not looking into high-level, early-stage R&D. We're looking into ideas that do have a path to commercialization, and we're looking to see this depicted in your application. So some sort of market research, target markets, and so on needs to be there, and will be part of how we review the applications. In terms of what we expect, I mean, phase 1, we are in general looking for some sort of initial analysis, identification of the market opportunity, what is the target audience, if it is a design project, some design, maybe early prototyping, and then more serious commercial type of prototyping and testing is typically for phase 2, if a phase 2 is awarded. And finally, I want to make a general comment that this CETO topic is open to both SBIR and STTR applications. So depending on what you are eligible, you can apply as either SBIR or STTR for each one of these subtopics. And if you are eligible for both, feel free to apply for both. There is this option as well. Having said that, let me go to each one of these subtopics. The first one is a fairly open subtopic on power electronic technologies for solar systems. So what we're looking here is for improvements on power electronics as they apply to devices that are relevant to solar systems. So we're looking into inverters, converters, optimizers, solid-state transformers, and the like. Some key areas of interest, again, we might be looking into innovative ideas here. So the topic is pretty open, but areas of focus could be like wide bandgap semiconductor materials and their use in solar power electronics. We're looking into multi-port systems that support solar along with energy storage or EV charging stations. So combination of multiple applications with one device that is of interest. One thing that we would like to focus on is functionality of inverters. So we have ideas about how inverters can provide better functionality, how inverters can provide the grid support services to the grid, and any new control algorithms or control schemes for achieving that. Good example is grid forming functionality for inverters. This is something that we are interested in. And ideas that improve manufacturability as well as reliability of the inverters or other power electronics devices are also of interest. What you need to keep in mind is that domestic manufacturing is a key area of interest for CETO. So we want to see ideas that have a potential for domestic manufacturing, and we want to see applications that have put some thinking into it and have make the case that this innovation could be manufactured domestically. These are the key aspects. And one other last comment that I will make on this subtopic, which is a general for all of them, we need to see the clear and direct impact to the solar industry. So we want to like to see applications that are much broader than CETO, and then somehow they can have some relevance to CETO in the future. We want to see applications that clearly address a solar problem, and they have an immediate solar application, and the application that you write is targeted and structured around the solar application, essentially. So that's for subtopic A. Subtopic B and C are more on concentrating solar power. And I'm going to be a little bit more brief on this because I'm not the topic lead for these two. So if you have any questions, please feel free to put them in the chat or even email the appropriate mailbox, and we'll start monitoring it, and we can get back to you. Or I will transfer also your question to the topic leads who can provide more accurate answer. But the second subtopic looks into supercritical carbon dioxide power cycles, specifically for CSP. And we're looking into advancing both components, design, as well as systems around CSP. Looking into higher temperature performance, improved efficiency that goes beyond the state of the art, better cost and better reliability of these systems. And again, the focus here is to push the envelope with the state of the art. Subtopic C is again a CSP subtopic, but this is a little bit broader. It's not specifically focused on, like the previous one, supercritical CO2 power cycles. This is more general on solar power technologies for Gen 3 CSP, commercial CSP, as well as concentrated solar industrial process heat generation. So again, this is a fairly open subtopic on CSP. We are looking into raising the operating temperatures above 700 degrees Celsius and improving the efficiencies of these systems. And again, the key aspects here is that this topic is looking into components and systems that, and of course, materials that can result in low-cost electricity production or in industrial heat process production. So again, low cost is a key aspect of what we will be looking here. That's in general the description for subtopic C, and then going to subtopic D. Subtopic D is a more open solar subtopic. Looks very generally into new hardware and software technologies that improve affordability, reliability, performance, and manufacturing of solar systems. So again, this is a pretty open subtopic. Again, we are welcoming any new ideas here, any innovative ideas in the area. However, you need to be very clear about what the innovation is, how it improves state of the art with respect to solar systems, and how it adds value, either by reducing cost or improving reliability or demonstrating better performance. There are some specific areas that are clearly listed in the topics descriptions are not of interest, so please be careful with them and make sure that you understand clearly. And again, the overall idea here is that we're trying to capture any new concepts, any new ideas for solar technologies. There are specific examples that are listed on this subtopic as some focal points, but any other idea could fit this subtopic. That's kind of concludes my overall discussion. Zina, I will be happy to answer any questions. I did see a couple in the chat from earlier as well.
Yes, are you interested in EV supercharges that offer installation efficiencies with BESS and solar along with cost reduction?
Let me see this question again. Are you interested in EV superchargers that offer installation efficiencies with yeah, in general, this sounds like it is in scope, yes.
Okay. Another question for 17A. Does a prototype of a new type of high power transistor showcasing a novel operational mechanism and utilizing a unique material in addition to wide band gap semiconductor material align with the objectives?
So this is an interesting question, and you need to be very careful here. We need to see the relevance to solar. We need to see a solar application for that. So if the application, if the proposal is just for development of the material, and then somebody else can use it for solar applications, that is a little bit ahead of us, and that probably won't be of interest. But if you're building a solar inverter that uses this technology, then it is of interest. So again, it depends on how you frame it and how you make your case. But we want to see that the end product, for lack of a better term, or the end result of what you're proposing is a solar product. It's not something that somebody else will pick up in the future and will make a solar product out of it.
A person is asking for email address for the program manager rather than what is shown on the screen or included in the topic documents, solar.sbir@eedoe.gov. And also, can you please put the link for the December 4th webinar somewhere in the chat?
So definitely the December 4th seminar, I will put the link, and I will put the link also to the SBIR, SC to SBIR webpage that has all this information there. In terms of contact information, seat office has made the decision that we only want to communicate through this particular email address. So we don't really engage on one-on-one between the PM, the program managers or the technical leads and potential applicants, because otherwise we feel we may give unfair advantage to specific applicants. So feel free to email this address. We will be monitoring it, and we will be communicating any questions that come in to the appropriate people to provide an answer. But we avoid having one-on-one discussions with the potential applicants.
There is a question for 17C, mixed in PV and CSP for maximum CSP solar field capacity, not the most cost-effective use of PV, but indeed fills the space, picking up shaded sunlight and full sunlight, all grounds, you know. I'm sorry.
So yes, I read that question, I think, earlier, and I don't have a direct answer to this. I can't say for sure if it is responsive or not, and I can't give that immediate answer. It feels a little bit unconventional compared to what the topic is looking for. If you would like, I can kind of like relay the question to the topic leads and get a little bit of a more specific answer here. I would say that if you can make the case, of course, feel free to put in a letter of intent, and it will be evaluated at the letter of intent level. It's difficult to give an answer just based on this information, but I will say that it feels a little bit unconventional compared to what the topic is looking for.
Okay, there are two questions in the Q&A box. If you could stay online and answer those by typing the answers, we have to move to the next topic due to the, you know, where we going over time. Thank you so much.
I can try to answer them if possible. If not, I will kind of like relay them and get the potential answer.
Thank you so much. Thank you.
Thank you.
We move to topic 18, and we have Zion covering for Charles. Zion, are you online?
Hi, this is Rukhani. I will bring questions. Sorry, I will be going over the webinar for both C58, 18, and 19. I think there's an error in the email. The emails for both topics 18 and 19 should be for water.sbir@ee.dov.gov. Please do not email Charles. And yeah, we can fix this, but yeah, I will make this relatively quick because we, in the interest of time, I know there's a lot more to get through. Basically, we have two main topics in WPTO, that is topic 18, which is for fast track. These are projects that are funded through the bipartisan infrastructure law, and all three topics are focused on developing technologies and testing them in the water. The first is for community-centric hydropower development. The second is for developing and testing marine energy systems in open water conditions. And the third is for coastal structure integrated wave energy converters. Again, we are only accepting fast track applications for all three of these. We do have a webinar for WPTO on December 5th, when we will be presenting more on these specific topics. I sent the link to the hosts and panelists, so if you could please send that to everyone on the meeting, that would be incredibly helpful. We also have a WPTO SBIR page that I've linked to in the chat. But please check out the topics webinar. We will have subject matter experts presenting on these during the webinar, and you can bring specific questions on that. The next topic that I will be speaking to is topic 19, which is the next slide. These are WPTO's regular SBIR topics. So these are all for water power technologies. We are only accepting phase 1 applications for both for all 6 topics. These are funded through, are anticipated to be funded through our regular appropriations. The first 2 topics are cross-cutting across marine energy and hydro, where we're looking for concepts in emerging sensors, networks, and other monitoring technologies, as well as innovations in data analytics, models, and tools. Topic C and D are both hydropower focused. C is on pump storage, hydropower, and innovative concepts related to that. Topic D is on micro hydro development. And the last 2 topics are focused on marine energy. Topic E is on co-development of marine energy technologies. This is a topic that we have had for the last few years. And it is for the development of marine energy systems with in partnership with end users. And the topic F is on the development of subsystems and components for marine energy systems. So if there are specific questions, I can address them now. I'm sorry, I need to leave in a couple of minutes, but please do sign up for the WPTO webinar, where we will be able to go into much more depth on all 9 of these topics.
Thank you so much. Let me go through. There's a question that is between the difference between 18B and 19F. Could I submit the similar proposal if it meets the details?
So no, because topic 18 is fast track. So this is a combined phase 1 and phase 2. And excuse me, I believe the specifics of the application will be released in the FOA in the coming weeks. And topic 19 is only for a phase 1. And these are also 2 distinct topics. Topic B, 18B, is for the development of marine energy systems in open water conditions, and topic 19F is specifically focused on components and subsystems.
Thank you so much. And I'm putting in the chat the correct email for topic 18 and 19. We will correct that in the topic documents. I guess we answered that one. And topic 19, cross-cutting, B, innovation in data model and tool. My company maintain one of the largest, oldest 40-year history power generation. We proposed
yeah, I think on specific ideas, we definitely encourage you to come to the webinar. I am not the subject matter expert on on all of these subtopics, so our technical managers and subject matter leads will be there and will be able to better address these answers. So please do come to the December 5th webinar. In general, we always encourage people with ideas to submit a letter of intent. And we will, we will be able to better assess if something is responsive or non-responsive through that process.
What are the tool and programs the WPTO uses, and what are the gaps, challenges they currently face when using tools? What makes finding, collating, and analyzing data for specific hydropower and or marine energy application challenging?
I am not sure what this is in reference to. I mean, WPTO doesn't necessarily use tools because we fund research and we fund R&D activities. We do not necessarily use tools ourselves. We fund the development of the tools. So again, please read the topic in detail, including the linked references. And we also have a number of resources on our website, including to various data portals, things like Primar. And yeah, please review those and bring specific questions through our webinar.
19B, is this related to data collection or more of tools for data collection?
I would say both. Yeah.
Okay, both. There are 2 more questions. But if you could just answer them by typing the answers, that will be great.
Yeah.
And we'll move to the next topic. Thank you so much. Topic 20. Joy, are you online? Joy, are you online? Okay, I guess you can reach Joy via email with questions to topic 20. I do apologize about that. Topic 21. Mohammed, are you online? Gian, are you online? Okay, I don't see. Fernando, are you online?
This is Nico. I'm subtopic A. I'm online.
Okay, go ahead, please.
All right, so subtopic A is for the batteries team within Vehicle Technologies office. We have a fairly detailed table within the topic text detailing what is of interest and what not of interest. Very briefly, we're basically interested in technology that's more in the pre-commercial space right now as the technology gets more mature. We're less interested in that mature technology as it's well established within industry, and we're looking for kind of that next generation material and beyond lithium ion type systems there. As far as metrics to hit, you can take a look at the links that are provided in the topic text as well, looking at the USABC standards for sort of performance metrics are applicable for vehicle applications, as well as some of our past annual progress reports to see what kind of our targets are within the DOE, specifically looking at what sort of cost targets are relevant for our space. As far as what systems we're more or less looking at, we primarily will look at cell level technology. We're not interested in the module or pack level technologies, so those would be out of scope. So please make sure that all proposed projects are within that kind of cell level technology realm. As far as kind of the partnerships, no partnerships are required. Obviously, it looks good if you are partnering up with someone who has experience making cells, as building cells consistently is a bit of a challenge. But again, nothing's required. One thing to keep in mind for phase one, due to the timeline for applying for phase two, is it's more or less kind of an 8 to 9 month project. So make sure you are keeping that in mind as far as when you're going to get the cells on test to be able to get enough data to present a convincing project for phase two. So you're going to have a kind of an accelerated timeline there. And that's the kind of the key things. So in the interest of time, I'll pass it off to Fernando.
All right, thanks, Nico. So Fernando Salcedo here, Technology Development Manager for the electrification team in VTO. And the subtopic is on high voltage, half-bridge silicon carbide power modules for high voltage electric vehicle charging systems and solid state transformers. So as I'm sure many of you are aware, the supply chain constraints for wide bandgap power modules, as well as like low frequency transformers, have created significant delays for EV charging installations, bulk generation deployment, as well as grid infrastructure upgrades. Many of which have seen delays of more than a year, sometimes even 2 years, depending on the power level needed. Advancements in power semiconductor technologies, power electronics increase the opportunity for scalable and modular solid state transformers to accelerate this high power EDSEs and DER deployments. So unfortunately, there are currently a limited number of manufacturers for high voltage, greater than 3.3 kV high current power modules in the market. So most of which are designed for application specific characteristics and are produced at lower qualities. And this makes these devices really costly. So the subtopic seeks to establish a US domestic manufacturing capability with a cost structure that will allow for commercialization of a competitively priced product for global marketing based on innovative packaging solutions. This topic intends to also find innovative, low-cost, efficient, and power-dense solutions to improve availability of wide bandgap, high-voltage power modules for utilization in high-power EV charging, whether that be DC fast charging, extreme fast charging, megawatt charging, as well as grid-tied solid-state transformers. So for this subtopic, we're interested in wide bandgap power semiconductor technology, specifically silicon carbide, and half-bridge configurations for use in high-voltage, high-power applications, more of the details of which are provided in the full subtopic release. We encourage proposals to utilize package power densities similar to commercial off-the-shelf high-voltage power modules, as well as device pathways towards domestic manufacturing with a cost structure that will allow for commercialization at competitive prices. I'll be happy to take any questions. And thank you. I'll pass it to Avi.
Thank you so much. Let's go through all the subtopics and then take questions at the end. Avi?
Hello. I'm Avi Mirsky, a technology manager for energy efficient mobility systems, EAMS. EAMS supports research and development at the vehicle, traveler, and system levels. This multi-level approach is critical to understanding opportunities that exist for the overall transportation system. The EAMS program welcomes applications developing innovative solutions that improve transportation efficiency through methods such as greater coordination, communication, control, reliability, and increased utilization of efficient resources, analysts, and other system-wide applications. And let me emphasize system-wide, We're not looking for individual vehicle components, but systems of either vehicles or vehicle components. Examples of technologies of interest include, but are not limited to, technologies that improve transit optimization, technologies that enable first mile / last mile connectivity, that is connecting transit to other modes of transit, microtransit, such as bikes, technologies that increase transit utilization, spontaneous cooperative adaptive cruise control / platooning in actual practice, technologies that enable electrification in alt fuels or encourage them in practice, and retrofitting of existing vehicles with innovative technologies. We expect successful applications to clearly address the inefficiency and problem that they are tackling, and clearly show how the solution will improve efficiency and how this will be measured. We also expect applicants to show a pathway towards delivering their solution to customers. We are not interested in applicants that are just straightforward implementations of existing technologies and solutions. We are also not interested in applications that are focused primarily on procurement. On that note, we do recognize that smartphone applications are a way of increasing coordination and communication and can be part of a shared mobility solution, but applications whose efforts are primarily in app development rather than technology development are discouraged. We also don't want to see applicants that are duplicative research that's already in progress of VTO, which you can see in our website, as well as other agencies, including state, local governments, and by the private sector. So submissions should clearly explain how their work differs from other work in the field. The area of, for instance, of shared mobility is an area of active research and where many jurisdictions have pilot programs. The intent of this SBIR subtopic is to complement those efforts and go beyond them. Thank you.
Thank you. Felix, are you online? Okay, Nick, are you online?
Yes.
Go ahead, please.
Last but not least, I suppose. So we're just looking for I'm sorry, we've identified that in the DORMA, that's the decarbonization of off-road rail, marine, and aviation, that biofuels and biofuel blends are likely to be a pathway for the foreseeable future. And one of the things we have seen is that manufacturers of engines would like to know on vehicle the concentrations of biodiesel so they can adjust their calibration and their operation accordingly. The ones that are out there now are sort of your laboratory and very expensive ones. So we're looking for projects to help with that. That's all I have. We can turn it over to questions.
Okay, thank you. Are technological solution expected to be user installable or installed by off-road vehicle manufacturers?
Primarily OEMs, I think, is the expectation.
Okay. Let's see. 22C, would system-wide innovation apply to technology that drastically reduces the heat pump, electrical power demand for thermal comfort conditioning?
I'm not entirely certain I understand that question that I heard, but from what I heard, I don't think so.
Okay. Would efficiencies in charging technologies and installation efficiencies be of interest also to 22C?
Potentially, it would have to be, once again, something that is showing beyond a single component or application. So not just an increased efficient charger, but if you are organizing how you are charging a fleet of vehicles, that would be of interest.
Okay, the last questions are applications related to electric heavy-duty trucks considered responsive?
Yes, any and all vehicles.
Thank you. I don't see any more questions for topic 22. Thank you so much all for attending. And as you can see over here, this is the contact information for our office. We mentioned at the beginning of this webinar that we will post the presentation and the recording of the webinar on our website under Funding Opportunities webpage. Here you have contact information. Please feel free to reach out directly to Mr. Carl Hebron, who is the operation manager in our office. Carl and his team can answer just about any question you may have about the application process. And I did see some questions submitted and that are related to the application process. So please, you can either contact us via email and or also attend the webinar on December 15. I would also point out that DOE has a Phase 0 Assistant Program, which is open to all first-time DOE applicants. So if you have never applied to DOE before and looking for application assistance, I encourage you to go online. You can find the link here or go to our website under applicant resources page and click on the link. That will take you to the Phase 0 website where you can complete a 3-minute application to see whether or not you are eligible for that service. It is a first come, first serve service, but it's something that can help you go through the application process. That will be it for today's webinar. We have one more webinar, as we indicated earlier. If you are interested, please go to our website and register for that webinar. Thank you all for attending and have a good evening.